Lesson 5.6, Inverse of a Function. Our essential question. How do you find and verify the inverse of a nonlinear function? Standard 5.6, number 5, finding the inverse of a radical function. So it first wants me to consider this function. This function is along the lines of a parent that is the square root of x. The square root of x ends up looking like this. Is this inverse? Is the inverse of this going to be a function? Well, do I end up passing the horizontal line test? The horizontal line test, horizontally, does it cross in more than one spot at any given time? It does not. So this does pass the horizontal line test. And that tells me that if I were to find the inverse and graph the inverse of this fraction, that the inverse would be a function. So now let's actually find the inverse. So I have the function y equals 2 square root x minus 3. Our first job is to switch the x and the y's. So this is x equals 2 square root y minus 3. And we need to solve for y. So I'm going to divide both sides by 2. I'm going to rewrite this radical as an exponent. So I can see my job is to raise both sides to some kind of exponent, because the only way to get rid of an exponent is to have those exponents raised to each other. Multiplying these two, 1/2 times 2 will 1 each other out, which means this is also to the second power. So I have x divided by 2 to the second power equaling these 1 each other out. I have y minus 3. This side, what is x to the second power? That's x squared. What is 2 to the second power? That is 4. I am now having to add 3 to each side. So I have x squared divided by 4 plus 3 equaling y. So I just found my inverse to be x squared divided by 4 plus 3. This is my inverse. I need to graph it. The only way to graph it is to use the xy table. So we're going to go ahead and use an xy table. So let's analyze this function real fast. Square roots, you know, have certain domains. This said on the inside that we were moved to the right 3. So my square root function was moved to the right 3. I now have a vertical stretch of 2. Let's calculate that vertical stretch of 2. I have to start my vertex at 3. So this is the coordinate point 3, 0. The rest of the graph has to go this way. So let's find this graph at 4. Let's find this graph at 5. And let's find this graph at 6. At 4, plugging it into the original function, I will end up getting a 2. Plugging in 5 to the original function, I'm going to get 2.8. Plugging in 6 to the original function, I get 3.4. This is going to be my f of x. So 3, 0, 4, 2, 1, 2, 3, 4, 5, 2.8, 1, 2, 3, 4, 5, 6, 1, 2, 3.5. So this is my f of x function. We are going to use this and its domain to help us determine the g of x function that we are looking at. I know because they're inverses that they should reflect on this line. If I started 3 to the right for my f of x, that means my g of x should start 3 up. So I'm going to start at the x of 0, and I'm going to see what my values are. But we also know that these two, the y values, become x's in the inverse. So 0, 2, 2.8, 3.4, and the x's become the y's. So 3, 4, 5, 6. So 0, 3, we're going to do 2, 1, 2, 3, 4, 2.8, 1, 2, 3, 4, 5, and 3.4, 1, 2, 3.4, 1, 2, 3, 4, 5, 6. Here is my inverse for my g of x. If I were to fold it along this paper, they would land exactly on each other. We found, because we know the square root of x, and so we found the square root of x, and then switched your x and your y's to find the inverse. Since our original f of x had a restricted domain, our inverse g of x also has to have a restricted domain. But g of x wasn't supposed to have a restricted domain the way we have it written. Right now it looks like it's just a quadratic function, but it's not a full quadratic. So we need to give this a domain restriction. Domains are our x values, so we need to say what x values we're allowed to use. The last x value used was 0, and I see I'm using all these positive x's over here. So this g of x will only work when x is greater than or equal to 0. Let's go ahead and do this problem. First, it asks us to consider the function, and this is the parent function, the square root of x. We end up looking like this when we graph it. We're first asking ourselves, will this pass the horizontal line test? Anywhere I draw a horizontal line, this will pass the horizontal line test. And since it passes the horizontal line test, if I am to find the inverse and graph the inverse, it will be a function. So the inverse is a function. So to determine whether the inverse would be a function, I did. Now I need to find the inverse. So my original problem is y equals the square root of x plus 2. I'm going to rewrite that as a exponent so I can see it. So I still have my original function. To find the inverse, we need to switch our x and our y's. So here is me starting to find my inverse, and now I need to solve for y. So I need to raise both sides to a exponent where these two exponents will multiply together and they'll give me a 1. So this is 1/2 times 2, so both sides are going to get raised to the second power. So this is x squared equaling 1/2 times 2, 1 each other out. So I have y plus 2. Solving for y, I have x squared minus 2 equaling y. That means my inverse is g of x equals x squared minus 2. So I need to graph these. So my f of x, I see, is a moved left square root. So it's a moved left by 2 square root. So let's go ahead and do an xy table. I know I can start it at -2, and I know it's going to go this way. So let's do -2, let's do -1, 0, and 1. So that was -2, 0. Use your calculator, plug in these other points. -1 plugged into the original function would have given me 1. 0 plugged into this function would have given me the square root of 2, which is 1.4. 1 plugged into here, then the square root of 3, which gives me 1.7. Let's do one more. Let's actually find 2. 2 plugged in is the square root of 4, which gives me 2. So I already did -2, 0, -1, 1, 0, 1.4, 1, 1.7, 2, 2. Here is my f of x. Well, now we want to find the inverse, which is g of x. And we don't need a table for this one. We know how to find this one. Since this one had a domain, this one needs to have the domain as well. So we are going to just reverse our xy's. The x's now become my y's, and my y's now become my x's. So I have 0, -2. I have 1, -1, 1.4, 0, 1.7, 1, and 2, 2. I see that it's starting to graph like this. And I can confirm that they are inverses of one another, because if I graph the line of reflection, if I were to fold on this dotted line, the points would all line up on one another. F of x had a restricted domain because square roots have a restricted domain. Since f of x had a restricted domain, g of x also got the same restricted domain. But the way that we wrote the g of x function, it's not restricted. This says it's supposed to be a full quadratic function, but we are not. So we need to restrict this domain. Domains are x values, so we're going to be looking at x values. The last x used was this x of 0, and I used all these positive x values over here. So this is when it's greater than or equal to 0. There are 2 problems left on the page. Please do these 2 problems for independent practice.